Okay, hello. Welcome to my talk, Infrastructure as Code in Action. My name is Thorsten. I would like to introduce myself as first. I'm working for a company called Novatec, based in Germany in the area of Stuttgart. And what I'm doing is currently leading a cloud migration in the enterprise scale project. I'm giving talks like this, and I'm giving workshops and lectures in universities, predominantly in Germany, right? What I'm talking about today is, I forgot. I need to talk about our company first. Well, they paid my flight in the hotel, so, right? So this is pretty small. We're doing a lot of consulting stuff and software engineering stuff and HR transformation stuff. What I'm pretty happy about being in Spain is that I can welcome here my colleagues from our Granada branch office, which is a very beautiful city there. And predominantly in Germany, we're doing a lot of things in the open source community with not only open source, but in Cloud Foundry community, in Scrum communities. We're doing a lot of meetups. So I think that should be enough of advertising. So Novatec is a cool company, so that's in general, right? What I'm talking about today is a migration journey from a project where we are signed with I think for 6 years almost. We are developing a backend for a connected vehicle application landscape for a well-known automotive client. So the technical details are something like that. Well, should I point on? There. Many requests, big code, and deployed in 3 geographies using 3 monoliths on WebSphere Java E6. A lot of backends connected. Backends like, there's a slide for that. So what I'd like to ask you at this slide is, did anybody see this stack before? WebSphere and DB2 and, well, JMS with MQ. Anybody worked with that? Hands up. 1. Well, then you know the pain here. Okay, so this landscape is communicating with a lot of systems. For example, with the cars, because it's a connected car, well, your car does like to share how many fuel is in the tank or how many kilometers you already drove. It is communicating with the factory or the dealer because the dealer wants to enable your phone to connect to the car. And it's connecting to probably another system which we don't know. Yeah? A lot of systems are involved here. And for some reason, I will come back to the reason later, the company decided, well, we need to go in the cloud. It was well known that not everybody, and not every system will go into the cloud. Some will say, well, that sounds like a hybrid cloud. You can call it as you want, but at least some systems are in the cloud, some not. So the move into the cloud is most probably because moving off from KPAX to OPAX, only paying things you want to, that you really use. They had a data center before with big VMs, with big licenses and all those things you may know from enterprise data centers, right? Some of the applications will stay, some of them will go into the cloud. So we developed 3 monoliths. One of them is pretty good, one of them is pretty bad, and one of them is totally useless. But what we wanted to do is developing microservice, which is running on a cloud platform which we don't want to manage at all, right? We want to write microservice with modern things. Some colleagues are that crazy that they would develop a microservice in Go or whatever, yeah? Using Spring or whatever technology you would like to want. So the way to go there is not possible with greenfield development. the applications are under heavy load. We cannot stop developing the applications, and well, say for 1 year we're re-implementing in cloud native. That was not possible. We need to find a migration path. And the first step was going from that big 30-minute startup application server to a pretty quick one, WebSphere Liberty profile, probably on my notebook. Then I'd like to test it on something what we call a local cloud platform. So what's a local cloud platform? For example, PCF Dev, Cloud Foundry Dev, or Minikube, if Kubernetes would be a thing. Yeah? And if that works out, we want to shift the monolith to the managed cloud platform. And I do have a 60 or 70 minutes talk together with a colleague where we only talk about this migration shift with live demo and also on. But that's not infrastructure as code in action, right? So this is the setup we worked in. Yeah? And once we made that, we want to develop microservices. So I forgot to start the clock. Right, so with that task assigned, questions and doubt arised. For example, on what will the application run? So will it be a virtual machine in the cloud where we start a Java-jar application? Is it a Docker container which we put on one VM, or is it Kubernetes, or is it Cloud Foundry, is it OpenShift, whatever? We didn't know. Who will bring it there? It is not just only the application, it is also a database of 1 terabyte size. Will I go to the customer data center with a flash drive and then drive over to the cloud data center and put it in? Actually, that was really a path, but it wasn't decided then. And how much power do we need to run the application? So we know there's heavy load, we know there were big VMs in the data center, but we didn't know how big and how many VMs do we need in the cloud for that. And the final question was how to maintain all those things. There will be databases, there will be VMs, there will be whatever, certificates that will expire, and all those things we didn't know, many questions. So as we didn't find answers to these questions within our customer, because they don't know it. It was their first cloud migration in that department, so they don't know it. We collected initial requirements. So for example, it has been decided for some reason that we should use Kubernetes and Docker. We should run on PostgreSQL and MySQL. We should ready for HA setups. Now it's getting tricky, right? We should run on Azure Public Cloud, use managed services. Don't use Jenkins and GitLab as before, but use Azure DevOps. And as I told before, the communication with the data center will still be there. But there's more. We should avoid vendor login. We should encourage team self-service. You're okay. 3 geographies and 2 stages each, and only 6 months left. So that was a tough one. And we started to think about, well, should we build a custom cloud platform? What is a platform, actually? A platform, in our terms, is an environment where our applications will run, and our colleagues don't have any administrative efforts. If they need a database, they can get a database. And we don't want to build a platform where probably your application will run on. We want to build one where our application landscape will run on. So I created an early draft and said, well, 3 geographies, maybe 3 Kubernetes with 1 container registry, probably 2 databases, because that 1 monolith is still useless. And the traffic will come in via Azure Managed Load Balancers. Okay. And there will be a key vault for handling the database secrets and the access certificates and whatever. Right, so that was an early draft. And then something, at least for me, unexpected happened. Our 40 people team discovered, well, there's cloud. we can use many things. We can use content delivery networks. We can use event-driven architecture with Event Hub. We can use blob storage. So this is Event Hub. These are functions. This is a content delivery network. This is blob storage. These are caches. So there are so many things out there to use. And we remember the question how to maintain all those things. This part stayed the same. Okay. That happened, and I found out we need to reproduce environments very quickly, because within the migration, the team started to create microservices, and there was not much knowledge about how to use a CDN or how to use Azure Functions. They need temporary environments, quickly set up and quickly destroyed only for the time they need to use. So some things have been automated within Azure DevOps. There was no Azure DevOps logo, so I created one with the Git. We discovered that we only need one repository, container registry, because the applications will stay the same across each geography. There will be the same application in America as in Europe. And we need a common key vault. For example, the connection, the infrastructure as code tool is making to Azure has some credentials. We need to store them centrally. So, has anybody ever worked with infrastructure as code in here? Did you use Terraform? Somebody used Pulumi? Okay, so we use Terraform. And what we use for a remote state is a centralized blob storage. So we do have a remote state for each application, for each geography. And that one is heavily used by the automation pipeline. Well, right. So that was a draft. And an environment in detail, this is just part of it. Many databases with replication databases, many event hubs which are storing their events into blob storages, Kubernetes in the middle, key vault, and caches replicated across all geographies. Right, so having that, we thought about what's the next thing. That worked, applications have been deployed, they were reachable on test environments, worked out. So, but is that all? We need at least security, right? Security is always good. And securing databases especially is very crucial for our project. In our applications, PRI, personal identifiable information, we have a lot of personal information in our application. 8 million customers, right? With addresses, with vehicle information, identification number, many information. So that it must be secured. Azure's basic setup is quite good. They do mandatory IP whitelisting. Not everybody is able to connect. You need to whitelist your IP address. They force you to authenticate and authorize. Well, you can enroll role-based access on that database. You can encrypt the data in transit with automatically configured SSL. And you can encrypt data at rest, not with bring your own key, that would be the customer's wish, but with a Microsoft managed key, which are probably better. Yeah? And they do have advanced threat protection just by clicking on it. Yeah? If somebody suspicious connecting to the database, somebody who shouldn't connect or didn't connect in a time, it creates alerts. So the question is that enough? For a very big company, this is definitely not enough. What about those colleagues here? They could be anybody. They could be, for example, engineers which are on call, because we're doing 24/7 on call in the night on an outage, which want to connect to the database. There are people which are not within our project. For example, the business intelligence people, probably creating some charts out of data. They want to access the database. So we need something better. And this is the first point where it's not all about, well, using the Azure Terraform plugin and it's all good. No, that was the first point when the action was there. We need to restrict database access per default. We need to make the access auditable and approvable. So for example, if Thorsten wants to connect a prod database at 8 in the evening, our PO should and should be able to reject those credentials. So this can be achieved if that didn't took long. So you just need to Google a bit, and you will find out a good practice is to put the access within one VNet, and it's a good idea to use the same VNet as your Kubernetes cluster is using. Well, okay, sounds good. Only the Kubernetes cluster is able to connect to the database, and then we need to deploy something, for example, a SQL editor into Kubernetes for handling an outage. Okay, so the problem is AKS does not, let me start another way. If you create an AKS, you will see that another resource group is automatically created where all resources that AKS is using are deployed to. For example, you can't read that, but this is the virtual machine. This is the network interface. If that would be a 10 node Kubernetes, there would be 10 virtual machines within that resource group. And there's our VNet. That's the VNet where our Kubernetes is connected to. And this is the problem. Those resource group isn't managed by Terraform. You cannot look up that in Terraform. So we need to find another way. Can you read that? Probably not, right? What we are doing here is we are looking for the VNet name. The VNet name is that one, AKS VNet, and an ID, which probably changes. It is not the same for each AKS. And we're doing that by running a script during Terraform run. Sounds stupid, is stupid, but the only option. This is data. That means this script will have a result. And these results will be used by another script, which is exactly as stupid as the first one. We create a VNet endpoint because you cannot create VNet endpoints with Terraform. What is a VNet endpoint? This one is MicroSQL. This tells Azure that a SQL thing, whatever it is Postgres, MySQL, or Azure SQL, probably Oracle SQL in the future, is allowed to connect to those VNet. So these scripts are executed via Terraform run. And this is another resource because we don't need further information about this endpoint. We just want this endpoint for being there. So we can, we don't need to memorize that. Right, so that was the first point, which was not nice. And with that, once that endpoint has been created, we can go back to usual Terraform. We can create a network rule, which, allows that subnet we just looked up before in order to connect. And by doing that, we created those processes which we want. This was one out of many, many things we found out during our migration. I gave this talk, I think 2 weeks ago or 3 weeks in Belgium, and I said, well, this talk could be last for 2 hours. Yeah, I can talk about 2 hours about things that happened. And the next thing I want to talk about is going live. Well, go live was doing data migration, bring the data there, do a lot of routing and DNS things, but Today I want to talk about the massive traffic and the impact that traffic had on our database. We are using Azure SQL for Postgres, Azure Database for Postgres SQL. And once the prod traffic came in, the database went down because our application produces so many requests on the database that it wasn't able to handle it. And we didn't choose a cheap tier. That was a big database tier, right? So we didn't expect that. And we faced that several times, even though we scaled up. So what we need during 24/7 on-call is something which is hailing us if there's probably a problem approaching. And what we learned is that while somebody is on call, those hails are something like to fear out. Yeah? What we have is a bot which is telling us, whoa, CPU usage too high, and mails that are sent out to the whole team. There is probably a problem. So what should there be a problem when the CPU usage of the database is too high? Probably not. But our system is not resilient. If that particular application is going down or getting slow means less than 40 milliseconds in response time. Probably application 10, 12, and 20 also went down. So no resilient system. It is important if the database does not behave as it should. You can do or create those alerting rules via Terraform. We are using Azure Monitoring Metric Alert, and this may be the first time you're asking, is he getting paid by Microsoft? No, he isn't. We just use a lot of that Microsoft things. And one thing which we, like to recommend if you're already on Azure is Azure Insights. You can use Terraform to create rules. For example, the rule here, if there's more than 70% of search already reserved, inform us, because probably that's a problem, right? And there are many more options for you to use Terraform to prevent probably action. Right, we remember high availability was a requirement. Whatever high availability means there. One option is having many instances of our application. This probably on many regions or whatever. What we choose is probably we need more Kubernetes. Even though we already thought one Kubernetes is bad enough, we introduced more on, for example, one in West Europe, one in North Europe. The problem here is that we need to keep both applications like warm, or we want to balance the load across those both instances. And if we remember our experience with those traffic from the cars and the dealers, we have been, let's call it afraid. We introduced DNS-based load balancing using Traffic Manager. Traffic Manager enables, for example, some rules. One rule probably is based on your geography. For example, if your request comes from North Europe, it goes to the North Europe cluster. Probably, and that's what we configured in the first place, is something like round robin or 50-50. There are many options within Traffic Manager. We didn't create that by clicking, we created it by Terraform. And what we did is creating Traffic Manager profiles, which is checking if the application is healthy. And only if the application is healthy, Traffic Manager will route any traffic there. And you remember that we are using many log tools and alerts based on logs and threat protection systems. And if we now imagine that there's somebody permanently asking, hey, are you there? Our systems maybe indicate, this is something suspicious. And that's why we introduced something like headers, which are telling our monitoring tools, hey, this is just traffic manager, it's okay that he is going to ask. Right, so that is one part of getting high available. I'm not talking about high availability databases. That's a huge problem we didn't solve yet. So going live, getting a bit more high available, that was, compared to going live in China, a piece of cake, right? I never thought that it will be that hard going live in China. Now I may ask, if you tell Azure Cloud is not the same cloud, it's not the same cloud. This is totally true. There's a different stack of Azure in China, and it is not the same. There's something in between which is called the Great Firewall. Did anybody deploy something in China? One. Did anybody know that there's a Great Firewall or knows what that is? Or sometimes it's called the Project Golden Shield. No? Oh, that's good. There was more to do. So there's no picture of that thing. There's no architecture diagram. That's why I illustrated it like a blur here. So I don't know what it is, right? That has some impact. The Azure instance in China does not have Azure DevOps. So we're using heavily Azure DevOps. Not nice, but we can solve that. We discovered that we need a container registry proxy. So why that? Somebody asked, somebody already worked with Docker? Okay, so then you probably know, if you deploy something on Kubernetes, it's probably a Docker container, and those container images consist of host names. For example, gcr.io/kubernetes-helm/tiller. Anybody work with Helm and Tiller? Okay, so Helm is something like a package manager for Kubernetes, and version 2 is using something which is deployed into Kubernetes. One part on my notebook, one part in Kubernetes. So, and I already told it. The container name for the tiller is that part which is deployed in Kubernetes, is gcr.io.kubernetes-helm and so on. The problem here is gcr.io. The Great Firewall blocks everything from Google. So you can't deploy tiller in a cluster in China. You need a registry proxy, and fortunately Azure and Google Cloud and Amazon Cloud, I'm not getting paid by Microsoft, yeah, are providing a proxy. And using that proxy, the container name is, I think, azurecates.cn.gcr.io/kubernetes-helm. Fun fact, if you compare the image size of both versions, it's not the same. So there's something else in the Kubernetes Helm from Azure Cates in China, and I don't know why. Well, probably I have an idea why, but I don't know what it is. Yeah? There's no advanced threat protection possible on databases or blob storages in Azure China. That means we can't enable that, but our Terraform script wants to enable that. And no encryption data at rest in China. And for some reason, I didn't find out why the CDN template is not available in Terraform using Azure China. So let's have a look on that. We need to build workarounds, and this is a part of our pipeline. And I think, at least for I know if I see that guy, stream editor, in a pipeline or in a script, I know this will be tough. At least for me, I always have problems with stream editor. What we are doing here is remove that advanced threat protection from Terraform script, because you cannot disable it. You can just remove it from the script prior to the run. And as we are just starting making our script ugly, we are, well, you can't read that. That's how you deploy something in Azure via Terraform. You have that resource and some properties. And what Terraform is doing there, translate that to something, using the Azure Terraform plugin, it translates that to Azure Resource Manager templates. So that the Azure CLI can put those on the Azure API and create the resource as you just described. And with CDN in China, that's not possible. You can do something else. You can deploy those templates also via template body in here. That means you need to translate everything you have in Terraform written down to Azure template. You can also use the Azure portal. It helps you a bit to translate that. But you do have two versions of your CDN. One version rest of the world, one version China. And that's because you need to use another Terraform file in China. Our goal was creating reproducible environments, and that was a break. There is no way to do that in China. We need to, the CDN is a bit different in China, but it luckily it does the job in almost the same way as it does in the rest of the world. Yeah, so I already mentioned Azure DevOps sometimes. It enabled us to use Terraform and the infrastructure as code part automatically. For example, each push on master. We are running Terraform frequently a day, but not on prod, because we want to have that approvable. And that's what you can see here is the run on the platform part on prod has been rejected by somebody because we saw in the plan results that something maybe break the prod. On non-prod, there was no problem because we are doing that automatically on non-prod. Somebody needs to have a look on what will be broken there. So, and this is now, let me turn it around so that you don't see my back. What I'd like to show you is this pipeline in action. I actually copied the customer part and removed all those customer things. So what you see now is not as complex as that thing we are having in prod. But if I now want to, just imagine I created something in Terraform and push that. Oh, that internet's quite quickie. Now I'm going to say, well, please enroll my changes on prod. I'm use Azure DevOps to create a new release, and my free tier is a bit slow here. So what will happen is that Terraform plan will be executed, and if I accept those changes, the changes are going to be applied to Azure directly. Oh. And I prepared this one before in order to make it not wait. That's how the Azure portal looks with a bad resolution. Terraform creates me application insights, Redis caches, MySQL server, Postgres servers, my CDN. This is the Europe instance, not the Chinese instance. And this is how our application infrastructure and platform is looking like. And we are on prod in time, so we made it within 6 months. I think 2 months later, we went to prod on America, and China is not on prod yet. Yeah. But a non-prod live, probably. So with that, whoa, I'm open now and later for questions. Yeah. So if you want to, you can also reach out by mail or Twitter or whatever where you found me, or ask questions now. Could be also a silly question. I will answer with a silly answer. No questions? Yeah, sir.
So how do you control, for example, if a Terraform apply fails? What do? You do some rollback? You check manually and try to solve the problem? Or?
Yeah. The question is how we test if a breaking how do we revert a breaking change, right? Yeah. Manually. Okay. Yeah. So sometimes we are lucky and Terraform stops before a break happens. But for example, that traffic manager thing, for some reason, if you run Terraform without changing anything on traffic manager, it removes traffic manager endpoints. That means 5 minutes later, your application does not get any load. And there's no reason. I reached out to the Azure support, they didn't found anything. So the thing we did is run Terraform again, and then it was recreated. But that's manually. So therefore, we enhanced our pipeline to check if all endpoints are still there after Terraform run and didn't apply anything to it. So breaking changes, the experience with breaking changes results in additional pipeline steps, which are checking did something broke which shouldn't broke. Yeah. There are many stories about that.
Sorry, I have a question about test environments. Did you hide? Did you hide your test environments by some VPN from internet?
No.
Do you have any plan to do that?
It is the decision of the customer is going on public cloud and not being restricted by corporate networks. The test environments for the developers are public on the internet, but secured by authentication and authorization to the UIs and to the REST endpoints. So the external endpoints are not public usable, and the non-prod environments are also public on the internet, but you need, for example, certificates for using them. Yeah. Okay.
Other question, what was the hardest part of migration to cloud?
The hardest part of the whole migration, IAM integration, security integration, as well as database migration. That was the hardest part. The hardest part to come is getting really high available, I think. So regarding those security integration is, let me take the example, using certificates in order to connect to the customer data center. Those certificates, managing those certificates with Vault was one solution, but getting there, that those certificates are automatically put in from the customer into the Vault, that was a hard one.
Okay, and last question, who has access to Azure in your team?
Yeah.
Developers or only some DevOps engineers?
They are treated equally. That means each developer can be a DevOps guy, which is on call. That means we are enrolling role-based access management. There are owners on subscriptions, which is something like like me, for example, because I sometimes onboard people on this platform. So I create access for junior and senior developers as well with the same permission set. But they can't go onto the prod database, for example, without those approval process we just had. They can't delete instances. They just can modify. And the only access given to altering the infrastructure is made through the pipeline. And those pipeline, as I just said, is auditable and approvable.
Okay, thank you.
Yeah. Further questions? No. But yet? Okay. Then this is the end. Thank you very much.